Now we'll move to one more concept called as supernode analysis. So what is supernode analysis? Right? The way we had discussed super mesh analysis, on the similar lines is supernode analysis. What was super mesh analysis? In super mesh analysis, there was a current source which was common to two mesh. If you remember, if you are studying regularly, you can identify what was super mesh analysis. In super mesh analysis, there was a current source which is common to two loops. In that case, then the two loops can be combined to form a super mesh. On the same lines is supernode analysis. In supernode analysis, there is a voltage source, right, which is common between two nodes. What is supernode analysis? In supernode analysis, there is a voltage source which is common between the two nodes. But what is very important is that the node must not be a reference node. That one of the two nodes must not be a reference node. Right? That is what is supernode analysis. Right? The two adjacent nodes connected between the voltage source are reduced. Then how do we solve this? Then the two nodes in between which there is a voltage source are considered as a single node and we apply the KCL to it. Okay, that is what is the concept of supernode. Now let me make you understand this in a much better way by looking at a particular problem. So look at this particular problem. Right, it says find the nodal voltages in the circuit, and they have marked us the nodes 1, 2 and 3 and 4. The total 4 nodes, and they have asked us to find the nodal voltages 1, 2, 3 and 4. Right. So first you identify what are the sources involved here. So there is an independent source of 40 volts. There is another independent source of 6 amperes, current source of 6 amperes, and there is one more source which is dependent source, which is a voltage source. This is a dependent voltage source which is controlled by a current. So it's a current controlled voltage source. Right, and what you observe that this current control voltage source is connected in between two nodes. So between node 2 and 3 there is a voltage source. Right, so the moment there is a voltage source between two nodes, the two nodes become a supernode. Right, what is essential? It should not be at the reference node. So this voltage source must not be in any way connected to your reference node. So we know that reference node is always this node. Right, so there must not be any voltage source which is concerned anyway with the reference node. So if this is touching anywhere directly to the reference node, then we cannot call it as a supernode. Right, but that is not the case here. This voltage source is connected between two nodes 2 and 3. Right, there is no association of this voltage source directly with the reference node, and hence the nodes 2 and 3 have a voltage source common between them, and hence the nodes 2 and 3 become a supernode. Now we can call node 2 and 3 as the supernode. So the moment we identify the supernode, what we need to do? Then we apply KCL together to this node. That is important. How do you solve supernode analysis? Is that once you identify the supernode. So who is the supernode here? The supernode here is the nodes 2 and 3. Right, they are forming a supernode. Why? Because there is a voltage source between them. So node 2 and 3 become a supernode. So the moment we identify the supernode, how do we solve it? Now we don't apply KCL separately to node 2, separately to node 3. Instead, what we do is we apply KCL together to this supernode. Right, we apply KCL together to both the nodes. Right, so how do we do that? So let us see. So now how many nodes do I have? How many nodes do I have? wherein I need to apply KCL. There's a node here at 1, then there is a super node. There's only one node now. Node 2 and node 3 are no more separate nodes. So there's only one node here. So one node at 1, one node which is our super node, and the third node which is node at 4. So only 3 nodes. We have reduced the circuit to only 3 nodes now. So we have to apply KCL to node 1, to the super node, and to node 4. Correct? So how do we proceed now? So we'll start by applying KCL to one of the nodes. So here first of all we have identified that node 2 and 3 are forming a super node. So we identified that node 2 and 3 is forming a super node. Now we can apply KCL to only 3 nodes. So let us start to apply KCL to the super node. Let us apply KCL to this super node. So as we just discussed, now node 2 and node 3 are no more separate. They are a single node. So identify all the branches now with respect to this node. Identify all the branches. The first branch is this, correct? The 5 ohm resistor. The second branch is this, which is the 20 ohm resistor. The third branch now with respect to this end is this resistor 15 ohm, and the fourth branch is this, the 2 ohm resistor. So in all we have 4 points, right? 4 branches to which we are going to apply KCL when we say we apply KCL to a super node. Correct? So we'll say apply KCL to a super node. So statement goes in a way, apply KCL to super node. Correct. So let us start to formulate the equation now. Let us talk about this branch. So it will be as usual we assume that the currents are outgoing currents. So V2 minus V1 by 5 is the current in this particular branch. When I talk about this branch, it is V2 by 20. Correct? Then I talk about this particular node, it becomes V3 by 20 by 15, and the last is this particular branch, so V3 minus V4 by 2. Right? These are the 4 currents which are associated with the super node. Right? So here you can verify now. The first branch was this V2 minus V1 by 5. Correct? Then it was V2 by 20, this particular current. Then with respect to this node, it is V3 by 15, correct? And V3 minus V4 by 2. This forms sum of all these currents is equal to 0 as per KCL. Algebraic sum of all these currents is 0. Right? Now there's one more thing that we can identify from this super node. Which is it? Right? That I have a current, I have a voltage source here, correct? So difference between these two voltages V2 and V3 must be equal to the voltage source. Right, now look at the direction of your voltage source. The voltage source has a positive terminal here and a negative terminal here. It means that the potential at point 3 is at higher potential than the potential at point 2. So I'll formulate the equation of only this particular super node. Right, what do I get? V3 minus V2 must be equal to the voltage 5Ix. So what do I get here? V3 minus V2 is equal to 5Ix. Why V3 minus V2? Because V3 is at a higher potential than with respect to V2 because of the polarity of the dependent source. Right, because of this polarity there is a positive here, negative here. V3 is at a higher potential than with respect to V2. So V3 minus V2 must definitely be equal to the voltage source 5Ix. Correct? Now I know what is my Ix. Where is the Ix current? Ix is the current which flows through this 5 ohm resistor. So how you can formulate the current for Ix? Ix will be the potential difference between the two nodes. So V2 minus V1 by 5 will be Ix. Right? What would be Ix? Looking at the direction of the flow of Ix. So it will be V2 minus V1 by 5. So I know Ix is V2 minus V1 by 5. Right, so if I substitute there, I get a relation which is nothing but V3, V2 and V1. I get a relation between these three voltages. So I got V3 to be 2V2 minus V1. Correct. I already had my KCL equation for supernode, right? And let me talk about V4. Look at your V4 voltage, friends. What is your V4 voltage here? V4 is this particular voltage. So V4 is the voltage from this particular point to the reference. So there is a direct voltage source which comes across it, and hence V4 has a value which is 40 volts. V4 has a value which is 40 volts. Right, so I know V4, correct? I have substituted V4 here. I know now V3 in terms of V2 and V1, right? So I'll substitute V3 in terms of V2 minus 2V2 minus V1, correct? And I get an equation which is in terms of only V1 and V2. So when I substitute here, I get the equation which is only, so if I substitute this V3, right, if I put V4 as 40, I get an equation which is only in terms of V1 and V2. So this is what we obtained by applying KCL to the supernode. Now we have one more node to go, right? The other node is this node 1. Now we'll apply KCL to node 1. We are going to apply KCL to node 1. So what are the currents? So first current is this, directly the outgoing current. So we'll take it to be positive 6. Current in this branch will be V1 by 10. Current in this branch will be V1 minus V2 by 5. Correct? There will be the three currents which we, and there is one more, yes, this particular. So V1 minus V4. There will be one more current, there is one more branch, V1 minus V4 by 6. So there are total 4 branches. 1, 2, 3, yes. Repeat once again, please. किती वाजता है? 12:30. Okay, I'll just stop in a minute. Okay. Okay, so applying KVL at node 1 is what I get here. Okay, so now you have two equations which you're going to solve, and then you get your equations 1 and 2. Okay, so solving, I have again applied Cramer's rule here. So using Cramer's rule, I have found the voltages 1 and 2. Okay, so I'll quickly just show one more example here which is based on supernode, right? So you can see here in the next question, you have a voltage source which is common to both the nodes, right, which is connected between two nodes, and hence this is again forming a supernode here, right? So apply supernode analysis and then you solve this particular problem, right? Okay, so here the complete analysis is shown to you, so follow these steps. So just I wanted to show you here that again this is forming a supernode. So nodes V1 and V2 are the nodes between which there is a voltage source, and hence you have to apply the supernode analysis here to the nodes V1 and V2. So if you apply the supernode analysis, you get these equations, or you can solve it and get the value of V1 and V2. Okay, so I'm just showing it. You can just later on pause the video, formulate the equations and verify the answer. Okay.